guys, Ray here, and today we're talking a little bit about polyurethane casting. So what I've got here are two exhaust hangers for my car. It's a 2000 Ford Focus, about 20 years old now, hard to believe. I had to replace the exhaust because the exhaust was going bad, and also these exhaust hangers were starting to get really stretched out, and they had too much play in them, so I wanted to get some replacement ones. And of course my car is getting a little old and it's really hard to find the replacements, so and they're a little pricey. So I thought to myself, well, I wonder if I can just redesign these. And my first thought was, hey, I could probably I know I can redesign them, and I could probably 3D print them. And so immediately I thought, well, these are a nice flexible polyurethane, and so I thought, well, they make a material called TPU, which stands for thermoplastic polyurethane. The problem with that is it's thermoplastic, which means when you heat it up, it melts. And as you can imagine, these go on the exhaust of a car, which gets hot. So having something that can melt at a relatively low temperature because you want to print it is a terrible idea for making exhaust parts. So then I thought, what if I can make a mold, something like this, that looks similar in shape, and then pour a 2-part polyurethane mix into the mold and create a polyurethane part. And I guess I've given away the punchline. I did it. But I'm going to show you how to do it, because I also made one critical error in my design here. Is I made the part too thin. You can probably see right there. Oops, too thin. My bad. Most designs aren't perfect the first time, but I did it. I created a mold. Let's see here. Actually, I created this one first, and I cast this part out of it. I went and found a polyurethane mixture that is roughly the same durometer as this material, actually just a tiny bit stiffer. You've still got some nice flexibility in it, but a little more rigid, and I was able to kind of make it a little bit more low profile, use a little less material than the originals did, because I want less flex. So I'm going to show you how I did that. I'll show you how I designed it, and then I'll show you how I printed it and poured the part, and here we go. This is the shell that I created for that rear exhaust hanger. Well, looks like a solid part if I look underneath it. There you go, you can see this is the shell. It's got that main, those undercuts here for the portion that you slide up through the frame and then twist to lock in. So that's nice. I'll just roll it back so you can see. What I basically did first was I sketched out the, well, I'll just show you so you can see the method behind my madness. I've got my my main sketch here. This is, you know, basically just drew out what the main profile would be for that hanger, extruded it, and put some radii on it. Drag that up. Oh, it wants me to finish the sketch. Okay, finish, and drag that over here. Got some fillets. I made that hole a little bit smaller for my second pour here, just to get a little bit tighter fit on the exhaust. And then once you do that, you select the shell function, and I shelled outward with a thickness of 0.9 millimeters. And I selected that main face up on the top, so it just punches that right out. So we've got our shell. But the problem was I've got this second cavity here, and when I'm pouring in here, I want to make sure that air can escape, and I actually would like to be able to pour there. So all I did was I created a sketch of that section, which, if you see it here, created a sketch, did a quick offset. The offset tool was, for whatever reason, it's hard for me to find. Right there, boom. And then I just did one more extruded cut to punch that section out. And so if it will let me, that's right, finish sketch. I literally learned Fusion 360 last week. I'm always more of a SolidWorks guy. But anyways, it's been a great tool. Actually, I'm more of an Onshape guy, because as you can tell, I'm on a Mac, and Onshape is much better. You can't run SolidWorks on a Mac. Anyways, what I need to do now is I'm going to go here we're going to save as an STL because I'm going to put it in my print prep software, and we'll just call it rear exhaust hanger 2, and pop it in the downloads. Then I'm going to put it in Cura. We've got our STL loaded of the new shell we're working on. This reveals that Fusion 360 in its default settings is one of those strange programs that thinks that Y is up, but you and I know better. So we're just going to reorient it. I'm also going to move it to a 45 here. And the reason I did that is because of the way Cura likes to arrange its support material. And as you know, this bridge that we've got here is, that's a big overhang hanging over in the air. It's going to have support material under it. I've already turned that on. But it's if you leave it the way it was oriented, it just creates these straight lines going across, and it is a pain to take out. But so orienting it at a 45 like this is going to put those at a nice 45 degree, be really easy to pop those out. So a few small modifications. I just went with a chroma strand, which is a PETG, well, that's technically a PET copolymer, but I'm just using that as my base profile, and then I've customized it a little bit. One thing that I've done is I've upgraded my TAZ to run on 1.75 filament because it's just more common, more abundant. You can get more filaments that way. So there we go. Filament diameter I've updated to 1.75. And then the other thing that I've done is increase that flow rate to 120. The reason I did that is to make the part waterproof. Now that I just did experimentally. I've printed a lot, so I knew, and I went ahead and tested it at 100%. What that means is 100% is the basic flow rate calculation. If you move this much, you have to spit out this much material that Cura does to produce its G-code file. So giving it 120, it's going to be spitting out 20% extra material all the time that it's extruding and moving. And the reason I do that is because there's little cracks, and when I printed this at 100, I went ahead and poured some water in it, and it just dripped right out like a shower head. It had holes all over it. So at 120, it sealed all of those up almost perfectly. It's just about watertight, and it's going to be more than enough for the pouring that we're doing. That thick viscous polymer is gonna be just fine in there. The only other consideration here, let's go ahead and go to layer view so you can see what that support material is going to look like. So we'll scroll down a little bit. You can see that support material right there, and this is what I'm talking about. Now you've got these nice 45 degree orientations. That's going to be a lot easier to get in there with needle nose pliers and just squeeze and pull that right out. You might be wondering, with increasing the flow rate, does that make the walls a little bit thicker, a little oversized? Yes, but it's such a small amount. And in this case, we're going to be pouring an elastomer into this mold anyways. It's really not going to be enough that it's going to be a problem to us. And we redesigned and closed up that hole a little bit, so it should fit really nicely. So here we go. We've got our G-code file. I'm going to save that. I'm going to toss it on the TAZ and print ourselves a mold. So here's that 2-part polyurethane that we're using. It's PMC 770 from Smooth On. You can see it's 2 parts. You've got your parts B and part A. According to the instructions, you use two parts of A to every 1 part of B. That's why it comes with 2 bottles of A. That's pretty simple. So we're going to use that 2-to-1 ratio to design some pouring and mixing vessels, and I've done this in the past. We're going to go design that right now so that we've got exactly the amount of resin that we want to pour in this part at exactly a 2-to-1 ratio. Makes it super easy to get this just right and minimize the waste. Let's go look at that. The next thing, we're going to want to print one more thing, and that is the actual measuring and pouring cup. And we want to make it exactly the right volume. So if we roll back to just before we did our shell function. This is what the actual part looks like, right? So we want to know exactly what volume this is. That will tell us what volume of material we have to mix. So I'm going to go to body here on the left, and then we go to properties, and you'll see we've got area, density, mass, volume, 4.352 times 10 to the 4th millimeters cubed. So I'm going to write that down, 43520 millimeters cubed. I'm going to multiply that by 2 and do a quick bit of math, and we're going to start designing a measuring cup. Now, just as a reminder, you don't have to do this. You can just, as long as you have some kind of measuring devices, cups of some sort that will allow you to measure out 2 parts of part A to 1 part of part B, and you just want to wing it, just mix up however much you mix up, that's fine. I just found it to be a little bit wasteful, and since, you only want to use how much material you need to use, this is a really easy and kind of cool way to measure out exactly how much resin you need to use. So just showing you what I did here, made a simple sketch of a circle. It's 70 millimeters in diameter, and done. And then I extruded that, and let me just show you, I extruded it to 50 millimeters, but actually you do a little bit of math, a little pi r squared, divide by the volume that we just got. So the volume for the 2 hangers we're going to pour was about 87,000 cubic millimeters. Divide that by pi times 35 squared here, and we get a height of 22.6. So let's go ahead and do that, 22.6, and that is the amount of resin that we're going to need to use. Just to confirm, go to properties here, and the volume is just about 87,000 cubic millimeters. So our math is right on point. The reason why, so that's exactly how much we need to measure out. We want a little bit taller glass than that, or taller vessel. So I'm just gonna undo that. I extruded it to about 50 millimeters, so give it about double the height. It's so little material to print this this vessel. You just want to make sure that you're gonna have to pour the 2 parts in, and then you're gonna have to stir it around. So let's make it tall enough for that. I did a little bit of fun here to go ahead and actually I'll show you. Firstly, what I did is now we're mixing a 2 to 1 ratio, right? So 2/3 to 1/3. So what I did here, I'll show you this sketch. I just measured out the side, along the side, and I went up 7.5, 15, and then 22.5. Since those are the amounts we're gonna, it's pretty nice numbers actually, that it came out to. And then I made these little circles, and what I did, as you can see here, is I extruded those circles in both directions. Boom. Just so that it notched out the sides of the vessel that we're going to use. So now we've got those nice notches when we go to print that. I put all 3 just in case I put part B first. I'll just go up to there, and then part A up to there, or the other way around. I had a little fun here and put a little spigot. I just drew a triangle, a second triangle, I lofted between them, and then I added that to the shape. Now this is all one solid shape, but then you do a shell out. I did an outward shell of, I'm pretty sure it was 1 millimeter. Yep, 1 millimeter out. Since I have a 0.5 millimeter nozzle, I just want a two pass thickness on all of the walls. And then just to be nice, I did a little, did put some little fillets on the bottom of the inside, and of this pouring spout right up here. So that's good to go. So we're gonna go as soon as the 2 pouring shells are done. We'll go ahead and print one of these, and I'll show you that. Alright, this part is very not technical. Here's our universal mold release agent. Here are our molds. And there we go, we've got those set up there. And we are going to hold our can about 12 inches away. Spray, spray. And you give it a little bit of time, and then you spray it again. Ta-da! Alrighty, we've got our mixing cup done. Here it is. A nice little spout on the front, and we've got our little markings on the side. So there they are. And that's going to be really nice. So let's go ahead and measure out some polymer. So I'm going to take our part A here, and again the instructions right here, they say mix at 2A to 1B ratio. So I'm just going to pour up to that second notch there. And we've got our part B. Good to go. Now we're going to do a little stirring. And there we go, mixed. All right, so now that we've mixed that, we are on the clock. We've got, what do they say? We got a couple of, not even 30 minutes of cure time. So yeah, once we've got that mixed, we want to go grab our molds, bring those in here, and start pouring. We've got our molds filled, and it's time to cure. All right, so these little guys are looking nice and cured. It's been 16 hours. The instructions are really cool. They say that you can give it a post-cure of 4 to 8 hours at 65 degrees. And so you'll see I've got them sitting on my print bed here, and I was just keeping them at room temperature because it gets cold in the garage. Now what I'm going to do is I'm going to take that bed up to 65 degrees, and what this is going to do is basically it's going to do, it's going to cure any last, what it's really doing is anything that's not fully cross-linked. Now it's going to heat it up and it's going to fully cross-link it. I'm also going to throw something on it to cover it up, and I'll probably rotate them, flip them over just like baking cookies. And then let's see how that does. Alright, so here they are, fully cured, and they're ready to come out of their little shells. So the main way I do this is with some wire clippers, and what we're going to do is, well, the most important thing is we're going to have to get rid of this little bridge that's over here. So we're just going to clip into that. I'm going to clip that until I'm trying to be careful. This is the kind of surgical part where you don't want to clip. You don't want to cut the actual part. I've done that once now, and it was like such a bummer. So we just want to clip very carefully around it. And what I'm going to do is I'm going to clip down this seam. So I'll get inside between the actual shell and the part. And we're going to clip our way down until we can get to the bottom, and then what we're going to do is once we've exposed the bottom, we can pretty much just pop the part right out. Okay, so here we go. We've gotten through the sidewall here, and we've gotten that little bridge piece out. Let's grab ourselves a little bit of prying action. And now we find out how well our mold release did. A little more mold release. Okay, let's try this. We're going to try to push these guys through with some needle nose pliers. I'm going to spread the pliers apart while I push. There we go. Look at that. There goes that piece. I'll just push them through here. There we go. last little piece here. And there we have it. There's our part. I'm very excited. It's looking great. Looks like it came out with just the geometries we wanted. It does have some bubbles up on the front, or on the top, you can see here. You know, some of the air bubbles do come up to the top. You know, you could put it in a vacuum while it's curing, but I don't have one of those, and I don't really mind it all that much. It's got a nice flexibility to it, but it's still pretty sturdy and rigid. I'm going to go ahead and break the other one out, and then the moment you've all been waiting for, does it fit on my car? Alright, I just got that one broken free, that second one. Before I throw it on the car, I just wanted to make a quick note to all of you, since this is kind of a DIY video. I've been using sharp things, pointy things, cutting things, things that can squeeze your fingers. Take caution, be smart. I wear glasses, so I have glasses on all the time. I also have been dealing with polymer resins. You know, wear gloves if you feel that's necessary. Just wear gloves. I didn't. I apologize. I should have. And you should too. Be safe, do cool things, and keep doing cool things by keeping yourself safe. All right, just want to say that. Bye. All right, here we go. Okay, so here is our part. That's the hole it goes in. So this square part on the bottom just pops right in, and you twist, and it locks in ever so nicely. Here is the piece of the exhaust that we need to get in there. This part takes a little bit of wiggling, a little bit of praying, and there we go. Woo! All right, and that is a successfully installed exhaust hanger. Thank you guys for watching. You've been awesome. We'll see you again soon.